This is 6.1, right triangle trigonometry. When we started trigonometry, we started from a unit circle approach, which is the most useful approach in calculus. But trig itself was developed from triangles. And so the first thing we need to know about right triangle trigonometry is the standard way in which we label the angles and the sides. If you have a right triangle, they're generally going to say that your right angle is C. And then, of course, that means that A and B are both acute angles. Angle C and side C are opposite each other, and C, the side, is the hypotenuse. Angle B and side B are opposite. Angle A and side A are opposite. And this is standard, so when you're just given variable values later, you know how to label your triangle. Uppercase is angles, lowercase is the sides. Now, we always talk about the hypotenuse, for one, that's always directly opposite your right angle, and it should be the longest side. And we use the words opposite and adjacent to describe sides A and B, and which is which depends on where your angle is that you're talking about. Opposite is always the one that's opposite the angle you're talking about. So in this case, opposite is side A, and adjacent is the one that's right beside the angle, so adjacent is B. If we had labeled this angle as our theta, then opposite and adjacent would be switched. Okay, so here are our trig functions in terms of opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then these are your reciprocals, cosecant, secant, and cotangent. So that's the same. A lot of people use the mnemonic Sohcahtoa to remember these relationships. SOH, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, Sohcahtoa. I learned the phrase, Oscar has a heap of apples. And you remember that they go sine, cosine, tangent, and your calculators have it in this order as well, so that can help you. And then it's just the first letter. Oscar had a heap of apples. It's up to you how you want to remember it, but there's honestly nothing new here. This triangle is exactly the same as this triangle that we used when we were talking about a unit circle. Everything here is defined the same way. It's just looking at it from a slightly different perspective. Okay? Now, our trig functions are the same for similar triangles. Similar triangles have the same angle measurements, but are proportional. They are scaled up or down, so the sides are different. And here you have three similar triangles. They all have the same angles everywhere. And the sides are proportional. So here we have a classic 3, 4, 5 right triangle. And if you multiply each of these sides by a 3, you get these values. Whereas if you multiply each of these sides by a 10, you get these values. And then if you apply the rules for sine, cosine, and tangent, you'll see that you do get this, end up, after you reduce the fractions, you end up with the same values. And that's really a useful concept. Okay? Let's work a problem here. We want to find the exact values for the 6 trig functions of the angle theta. Okay. Now, we need to know opposite, adjacent, and the hypotenuse. Now, we have values here and here, but we need one here. We need to use the Pythagorean Theorem. So I have 3 squared plus the square root of 7 squared equals c squared. 9 plus 7 is c squared. So c squared is 16, so my c value must be 4. Okay, so this is 4, and it is the hypotenuse. Here's our reference angle theta. The one that is opposite that angle is 3, so this is opposite. And that means this one is adjacent. Okay? So, sine of theta. Sine is opposite over hypotenuse, so it will be 3/4. And then that means cosecant, which is the reciprocal, would be 4/3. Cosine of theta is adjacent over hypotenuse, so square root 7/4. And that means that secant of theta is the reciprocal of this, which is 4 over the square root of 7, and then if you rationalize it, you get 4 square root 7/7. Now, tangent of theta is opposite over adjacent. So that will be 3 over the square root of 7, which when you rationalize it gives you 3 square root 7/7. And then cotangent is the reciprocal of this, but since if I take the reciprocal of it in this version, I don't have to rationalize, so square root of 7/3. Okay, so let's try this one. Given that theta is an acute angle of a right triangle, with cosine of theta being 1/3, find the values of the 5 remaining trig functions. So if you're not given a picture, draw a picture. Okay? We know we have a right triangle, and we know that theta is one of the acute angles. So you can choose either one to label. We know cosine of theta is 1/3, and cosine is adjacent over hypotenuse. So that means this is the adjacent, and this is the hypotenuse. And now I need to find this side. So using the Pythagorean Theorem, I have 3 squared minus 1 squared is equal to, let's just call that a for right now. A squared. So 9 minus 1 is a squared. A is the square root of 8, which is 2 square roots of 2. Okay, so that is 2 square root 2. All right, so we have cosine already. I'll go ahead and write that down and use it to get the reciprocal. So cosine of theta is 1/3. That means secant of theta is 3. Sine of theta is opposite over hypotenuse. So 2 square root 2/3. And then that means that cosecant of theta is 3 over 2 square roots of 2, which when you rationalize that gives you 3 square root of 2/4. And tangent of theta is opposite over adjacent, so 2 square root 2. And then cotangent is the reciprocal of that, which is 1 over 2 square root of 2, which is the same thing as the square root of 2/4. So you have all 6 or the 5 additional trig functions.